everyone, and welcome to Geometry Lesson 1-4, Pairs of Angles. In this lesson, we're going to look at different types of pairs of angles that we have and how they relate to each other. So let's see our first types of angles. The first term we have is adjacent angles. These are two angles in the same plane with a common vertex and a common side, but no common interior points. So basically, the angles are right next to each other. Okay, they share a side, they share a vertex, and they don't overlap at all. So angle 1 is up here, and angle 2 is at the bottom here, and there's no overlapping with the interiors of these angles. They're adjacent. Now, a special type of adjacent angles is a linear pair. So these are adjacent angles that form a straight line with those sides that they don't share. Okay, so when you're doing these and you're looking for these types of pairs, make sure you trace out the angles and you make sure that they share the vertex, and then you double check to see that this side is a perfectly straight line, and that would mean that angles 3 and 4 are a linear pair. Let's look at an example where we have to identify what types of angles we have. In example 1, we need to tell whether the angles they list are only adjacent and form a linear pair, or are not adjacent. So we're going to start off with part A, angles 1 and 2. So angle 1 is this angle right here. It starts all the way out there, comes in, and goes this way. And angle 2 starts here, comes into here, and goes that way. So to determine if they are adjacent and form a linear pair, or if they're not adjacent at all, what we do first is we find our angles and find their vertex. Notice both angles have B as their vertex, and they share this side, BC. So they share a side, and these other rays that come out and make angle 2 or angle 1 do not form a straight line. So they meet the criteria for adjacent angles because they share the vertex, B, they share a side here, and they don't overlap, and they don't make a straight line with their other sides. So what you're going to do is you're going to try parts B and C, and then press play to check your answers. In part B, you're asked to look at angle 2 and angle 4. So if I trace out angle 2, it starts here, it comes this way, B is the vertex, and then it comes this way. Now for angle 4, it starts over here, C is the vertex, and it goes this way. So it looks like they might share this side, this BC side, but guess what? They don't have the same vertex. C is the vertex of 4, and B is the vertex of 2. So these angles are not adjacent. Next, we're going to find angles 1 and 3. Angle 1 is here, and angle 3 is there. So let's trace the angle. For angle 1, it starts down here at C, it comes up to B, B is the vertex, and it goes this way. For angle 3, it comes in this way, B is the vertex, and it goes this way up through A. So they do share the same vertex, B. They share this side, BD, and they make a straight line over here. So that means they're adjacent because they share a side and they have the same vertex, and they are a linear pair because this is a straight line. So they're adjacent and they form a linear pair. Okay, make sure you write down any questions you have about this because we're about to go on to some different terms. Our next two terms are complementary and supplementary angles. So take a minute to write down what you remember about complementary and supplementary, and then press play to see what the definitions are and how to use those definitions to find missing measures. Complementary angles are two angles whose measures have a sum of 90 degrees. That means that if I take their measurements like 60 and 30 and I add them together, I will get 90 degrees. These angles do not need to be adjacent. They may be adjacent, but they may not. So you'll notice my two angles are not touching, they don't share a vertex, and they don't share a side. So these are not adjacent, but they are still considered complementary because their measurements add to 90 degrees. Now, if I was only given one of these angles, I could find the other one by subtracting from 90 degrees. So if I was only given a 30-degree angle and I was asked to find its complement, I would do 90 minus 30 to get 60 degrees for the complement. Now let's look at supplementary angles. Supplementary angles are two angles whose measures have a sum of 180 degrees. So you'll notice in the supplementary angles I gave here, 120 plus 60 is 180 degrees. Now, these angles do not need to be adjacent, but they may be. So I drew adjacent angles here because they share a vertex and a side. They don't need to be. They might be separated, and that's okay as long as the measures add to 180 degrees. Some pairs of supplementary angles do make a linear pair, like this pair right here. Because they are adjacent, they do form a linear pair. Now, to find the supplement of an angle, if we know only one angle, you would subtract from 180 degrees. So you do 120 subtracted from 180 will get you 60 degrees, and you can figure out this 60-degree angle using subtraction. So let's take a look at an example to see if we can apply these definitions. In example 2, we're asked to find the measure of each of the following. In part A, we need the complement of angle M, which is pictured right here. And in part B, we need the supplement of angle N, which is pictured right here. Now part B is pretty tricky, but see if you can follow the directions I gave for finding the supplement of an angle. And in part A, you're going to follow the directions for finding the complement of the angle. So pause the video, try and do that, and then press play to check your answers. For part A, I knew that to find the complement of this angle, I would just need to do 90 degrees minus the measure they gave, and that comes out to 63.2 degrees. Now, in part B, we had to do something that is similar, but we have to be careful because it's an expression. So take a look at what I did. It asked for a supplement, so I used 180, and I subtracted the measurement that they gave in that angle. Now, you need to be careful with the subtraction because the entire measurement is subtracted, so I put parentheses there. And that means that this negative, this subtraction, needs to distribute to both terms. So that's where this came from. And then all I needed to do is combine 180 minus 20 to get 160. And then the minus 2y needs to just stay there because it's not like to the other terms. So I combined my like terms, 180 and minus 20, to get 160. And then I kept the term with the y. So we're going to go over that more in class. Make sure to write down any questions you have about this. And then we're going to spend some more time in class talking about complementary, supplementary, and other types of pairs of angles.